Visual Studio 2008 adds specific support for LINQ to SQL Server data. There's a system.data.link.data context which provides a simple-to-use wrapper around one or more SQL Server objects. That is, a layer between you and the data, which makes it real easy for you to work. This creates a hard-coded schema which is mapped to the original data. Now, when I say hard-coded schema, that means when you create your data context class, at that moment, it sucks in the schema. So if you modify the schema, your data context no longer matches your data. For more robust applications, you might want to investigate the entity framework, which was due out after the release of Visual Studio. It probably is out by the time you get this. And that allows you, it's more complicated, but allows you to create more robust applications that automatically generate the classes that map to the schema. The entity framework provides a real mapping layer between data and objects. But for now, we're looking at LINQ to SQL. And there is a designer in Visual Studio that makes LINQ to SQL easy. Now, if you know your schema isn't going to change, or if your schema is well known, LINQ to SQL works great. To create your data model in Visual Studio 2008, add a new item to your project and add a LINQ to SQL classes instance. We're going to try it out using the Northwind sample database. I use Northwind because it's easy and everyone understands it. Let's look at adding a LINQ to SQL class to our project using Northwind. To add a LINQ to SQL class, I'll right-click on the project and choose Add New Item and choose LINQ to SQL Classes. Now, I already have a LINQ to SQL Classes added for Northwind, so I'll just call this Demo for now. We'll actually throw this away once we're done. I'll close this window to get some extra real estate, and now we'd like to drag some data over from the Server Explorer, but we haven't yet set up any data connections. So I'll right-click and choose Add Connection. And here I'm going to use SQL Server. Click Continue. And in this very familiar dialog box, I'm using SQL Express on my current machine. And I'll use the Northwind sample database, which I've downloaded and installed already. Once I've set up the connection, I can expand that database all the way down to tables, and choose all or parts of one or more tables. I might just want a subset of a table, so I can control-click on whatever fields I want and drag them on, and the designer creates a class that represents just those three fields from the customer's table. Notice they named this class Customer because it represents information about a single customer. I deleted that. Now if you want the entire table, just drag it over. Say Customers, and maybe Orders, and you'll notice that the designer also infers the relation between the two tables. If you want to see more of it, you can zoom so it fits in the space you have, which is helpful. But you know what? We're going to want to also add to this a stored procedure. So we can go down to Stored Procedures, expand that node, and drag over a stored procedure into this right-hand area. This is where methods go, and you'll create a new method called custOrderHist with a parameter, let's see if we can see the whole thing there, with a parameter which is of type string named customer ID. Okay, well, we could save this, and it would generate for us a customer class, an order class, and a method corresponding to this stored procedure call, but I don't want to do that. I really don't want to save demo because I've already generated the classes I need. They're in the northwind.dbml data context. So let's look at that. I'll go to Class View to see what's in there. Close our properties for now. There we go. Let's expand this out. You'll see here in LINQ Demo, we have a bunch of classes like Category, Customer, Employee, and Order, Order Detail, Product, Shipper, and so on, that correspond to tables within the Northwind dataset. Pretty cool how they notice that those are plural names and strip off the S in English. I have no idea what they do in other languages. And that's all well and good, but we need collection classes. And those appear here under the Northwind data context. If we look at the various members exposed by that Northwind data context, we find methods like delete category, delete customer. We have insert employee, insert customer. So we have strongly typed methods for working with instances of those classes. And we also have, way down here, collections of those classes. We need those in order to be able to use LINQ to iterate through the collections of the classes we get back when we retrieve data from the actual database. Now that we've seen the data context, let's run some code that interacts with that data context. I'll click the Query SQL Database button, and here we'll first start by creating an instance of the Northwind data context class. I could have used the var keyword. I didn't. Either way works fine. Once we create an instance of Northwind data context, which, by the way, the designer named for us. I named that class when I created it Northwind, but they tacked on data context as the name of the generated data context class. Okay, so I've got my DB variable, and now I'd like to retrieve a list of all the products whose unit price is greater than $5. I want to order by category ID and then product name. Pretty easy to do this, because I can say var products, that's a result from our query, equals from product, that's our looping variable, in db.products. Remember, the data context provides a property named products, which is a collection of instances of the product class, where product.unitPrice is greater than 5, there's our where clause. We have an order by, which specifies two fields to sort by, select product. Now that retrieves for me multiple instances of the product class, and each one of them I'm referring to product as I loop through them. And now I can display the results. Again, since I'm calling the toList method, display results will display the results in a grid. That's how I've set up that little overloaded version of that method. And here we see the results sorted as you specified in the query, in a grid, where we've pulled the data from SQL Server. Okay, how about the stored procedure thing? Well, let's step into that bit of code here. We start again by creating our instance of the Northwind data context class. And now say you want to retrieve all the orders for the CAC2 customer where item.total is greater than 10. Well, db.custOrderHist will call the stored procedure for that customer ID. It'll return back an enumerable list. We can use the where clause to specify just the ones we want to actually work with, and we'll select item. Now, it's important to remember that because of delayed execution, nothing's happened yet. We haven't used the items, so we haven't actually executed the query. We can try a different way of doing it. We can reset that query to be some other expression, and here we're using the where extension method instead, with a lambda expression that specifies which ones we want to retrieve. I use the same exact expression just to prove the point, so you can compare them. It's like a little Rosetta Stone of lambda expressions. So you can see how the complete query compares with using an extension method and a lambda expression. Either way, we get the same results. And at this point, when I try to display the results, the code actually runs to retrieve the data, run the query, get the results, and display it on my form. Here we see a list of all the products in that customer's orders where the total is greater than 20. Just as you can use anonymous types with any other kind of LINQ expression, you can use them with SQL, because really, all you're doing is link to objects once you create that data context. So the code might look something like this. If you want to retrieve not the field named category name, but you want to call it category in your output. In this expression, we have an anonymous type, who knows what it's called, but we're using the product name field and a category output field. Notice that if you don't specify the name for the output field, it uses the name from the input field. We'll have a property named product name and a property named category in the output type from this query. Let's run the demonstration that shows off this behavior. I'll click the Using Anonymous Types button. This will take me to code that runs the example you just saw. I'll set up the Northwind data context, and now I'll create an anonymous type with product name and category fields. There we go, and we can even see that now, because if I want to do something with that products collection, you're going to see that it just has those two fields. I'll display it in a grid, and you can even see the results here of running that query, the select statement that was created for us. Let me run it, and you'll see we have product name and category. Not category name, but category, because that's what we specified in the output of our query using this anonymous type. The system.data.link.data context class, that is, the base for your data context, allows for data updates as well. It generates methods for performing updates against the data. Now, these updates use implicit transactions. If you want finer control, you can use your own transaction scope around the code you write to perform the updates that allows you to have complete control over the transaction. You call the submit changes method to save your changes. If you don't call submit changes, things aren't saved. Now we're going to use the LINQ single extension method as part of this demonstration. Now the way the single extension method works is it returns a single matching data item. Normally, a query returns a collection of items. I want to be able to work on a single return value, not a collection, and the single method returns a product or a customer or a category or some combination of those. And it raises an exception if the query returns more than one value or zero values. That means if you don't find exactly one result as the result of running this query, you're going to get an exception. And when you're modifying data, that's really what you want. You perform the query, you assume you get one result back. If you don't, you raise an exception and you deal with it. There are other ways to do this. There are other query extension methods that get you the same sort of information without raising an exception, but in this case, it seems like it really is an exception. If I want to find a particular row, and yet I find 0 or more than 1 rows. Let's try the demonstration, which shows off this behavior. I'll click the Modifying SQL Data button, and this takes us into our procedure. I already had a breakpoint here, which I'll remove, which allows me to modify data. The first thing I do is create that Northwind data context instance, as I've done in all of the other LINQ to SQL examples. Here I'll start by creating a new customer. Now I could have done this with an object initializer passing the information as I create the instance, but in this case I didn't. I used old style techniques. We'll create the instance, set some properties, and we'll call the InsertOnSubmit method of that customer's class. The InsertOnSubmit method allows us to indicate that we'd like to perform the insert, but only once we submit changes. So we're ready to go. We haven't changed anything yet. And to prove that, I'm going to retrieve the data from the customers table using the where extension method, saying only show me the rows where customer exists, where the customer's company name contains AAA. And this should certainly match. Yet if we run this, nothing appears. Why is that? Because we haven't yet submitted the changes. Back to here, let's now find the single customer whose customer ID is CAC2. Now remember, the single method here will raise an exception if this expression returns more than a single match, or 0 matches. In this case, we find a match. Let's go modify that contact name by preceding it with an X. We've changed the contact name. No more code than that is required to do the work. But all we've really done is change it in our class in memory. We need to submit it back to the database. We haven't done that yet. Let's try deleting an order detail. We'll find the order, which is the first order for this customer. We do that by specifying customer.orders. Now the reason that exists is because the database had a relation between customers and orders, and this code is just walking that relationship to find the first order for an existing customer, and that's pretty amazing. We can do the same now for an order detail. And notice that I'm assuming that there was a first order and there was a first order detail. These will raise exceptions if we try to work with null references. I could have added exception handling. I didn't in this case. Now I'd like to delete that detail that we just found here. I call the delete on submit method of the parent table, order details. It's actually a collection of order details records. I'll call the delete on submit method, which actually performs, well, no, it doesn't. It only sets things up for deletion. It won't do the deletion until we submit changes. And now it's time to submit those changes. I call the submit changes method and things change. We add the new customer, we modify a customer, and we delete an order detail. Done. At this point, we've actually added the customer. So if we ask again to display the results for all the customers containing AAA, we actually get a customer containing AAA this time once we have made those changes. Now you might want to clean up from these changes, and it's easy to do. I just go to my customers table here, right-click, choose Show Table Data, and let me modify CAC2 to remove that X there, and also delete AAAAA imports. Don't need that row anymore. So now if you do further work with the customers table, at least it looks like what it did originally. We have deleted one order detail, but who's going to miss one order detail as long as you're not a bookkeeper?